After theory, that's a theory examination, there will be the practical. And before the examination, we need to conduct the experiments. But in this pandemic situation, online experimentations will be there. Means through your device, maybe the mobile or PC, you can perform those experiments. And after performing those experiments, you will get results. Exactly what kind of experiments are there, how to perform that, everything I will inform to you. And that instructions will be common for all 38 students. Titration experiment. In titration, what you do, you take a solution in the burette, you pipette out the solution, then you perform the titration using indicator, color change to remain there. So all those things will be there in the simulation kind of the experiment. In spite of actually filling the solution, with the help of that the software, you can do all those things, even washing the pipette, rinsing the pipette, all the things. So the steps involved for the titration will be what very clear cut. In regular actual practical, suppose if one student has not rinsed the pipette, we do not come to know. But here, if you do not rinse the pipette, software will not go next. Error it will show. Marks will be less. In regular experimentation, we do not come across those errors. And student thinks that that's the correct way. Without rinsing, we can proceed. Wrong way student considers it as a correct. But here there is a no chance. Exact procedure you will know. That will be the advantage of that simulation experiment. And that we are going to start after your theory examination. And after our instructions, a practical examination will be there. How exam will be there? In due course of time, we will inform to you. Is it clear what I'm saying?
Yes, sir.
Yes, sir.
Yes. Today, let me cover one point, very important point. That's screening or shielding. Both screening and shielding are the same phenomenon. See, this a phenomenon occurs when are these words readable to you? Is this font readable?
Yes, sir.
Yes. The phenomenon occurs when nucleus reduces its force, means its force of attraction decreases. On whom? Valence electrons, due to presence of electrons in inner shell. And by the way, presence of electron in the same shell also, that also affects. Same orbital also, that also affects. So here they said it as what the inner shell. It is true. By the way, neighboring electrons also we need to consider. So actual attraction experienced by the outermost electron is less rather than expected. That less, that decrease is none other than the screening phenomenon or shielding phenomenon. Here they said it has what the effect. Outermost electrons experience attraction from the nucleus and repulsion from the inner electrons, due to which, due to repulsion, the actual attraction decreases. As attraction between nucleus decreases, the repulsion increases between the inner electrons and outer electrons. I mean, what they want to say, attraction is less means repulsion will be more, and repulsion means what, that the screening or the shielding effect. It is defined as the reduction in the effective nuclear charge, means whatever the force or power was expected from the nucleus by the electron, that reduction is there, that decrease is there. That effect is called as screening effect. Wider the electron shells in the space, the weaker the electronic interaction between the electron and the nucleus due to screening. Means if electron is at long distance, large number of students are present in one class, then last best students will experience shielding. So if wider is the range, wider is the position for the electron, then the screening will be there. Screening for what? Nuclear attraction will be there. Other way, higher is the nuclear force of attraction, greater is the ionization enthalpy required. Means they are comparing with what the ionization potential or enthalpy for the ionization. If nuclear power is strong, nuclear power is more, then it is difficult to remove the electron. Ionization enthalpy will be what, the high. So screening and ionization, they are inversely proportional, that they want to say. So it is additional point they have covered, or while discussion also during ionization potential, periodic train. I told you about the screening or the shielding. So it is also one important point. S orbital is more penetrating than P, which is more penetrating than D, which is less after all. That's what the F. So screening effect is more for what? That's a S orbital, then P, and then D, and then what the F. It depends upon their sizes. Penetration is the one thing. Here, what we are talking about, the S orbital relatively what the compact in size. P orbital somewhat diffuse. D orbital more diffuse. F orbital more diffuse. Diffuse in the sense spreading is more there. Because of the spreading, the electrons present in those orbitals will experience the less interaction, less repulsion. So this point is related to the spread of the orbital, diffusion of the orbital, orientation of the orbital, shape of the orbital. Yes, are you following? At the beginning I said penetration, that point is that there's a different. S orbital is more penetrating, means can fetch the more attraction. But here the point is regarding the arrangement, alignment. So because of compact shape of the S, the intra-electronic repulsion, intra I am saying, intra means within the same atom, within the same orbital, that repulsion will be more. In case of P, some more space is there. In case of D, further more space is available. Means diffusion is there, diffused orbitals there. In case of F, number of electrons are increasing. But by the way, orientation of the shape of the orbital in such a way, considerable difference is there, distance is there between the neighboring electrons. So screening or shielding because of that will what decrease. But if you see the penetration, then S orbital will experience the less kind of the shielding compared to P. So here point discussed is regarding the shape of the orbital. Students, are you following what I'm saying?
Yes, sir.
Yes. If we have to calculate actual how much shielding constant is there, shielding phenomenon is there, then we need to consider these three steps. First step, we need to write the electronic configuration in this format. Here groupings are there. For that you should know the electronic configuration point and you should know the groups. Pay attention towards these groups. 1s itself is a one group. 2s and 2p, it's a one group. Means here first shell, second shell. But after that see, 3s and 3p is a one group. Actually 3d belongs to same shell, but it is not in the group of the 3s and 3p. Who? 3d is not in the group of the 3s and 3p. 3d is a separate group. Then 4s and 4p. Then 4d, 4f, 5s and 5p. Afterwards, there should be what? The 5d, 5f. Actually, it depends upon the sequence, how we can proceed. But up to this much orbitals, the knowledge is sufficient. So what is the sequence? 1s, complete one shell, 2s, 2p, second shell, 3s and 3p are in one group. 3d is the next group. That grouping is very important. Is that first point of grouping clear to you?
Yes, sir.
Yes.
Yes, sir.
Then what you have to do? You have to identify the electron of our interest. Where is that electron? In which group that electron? And ignore all electrons in higher groups to right side of the step 1. They do not shield electrons in the lower group. Means what? If I consider electron in this group, for example, say sodium, atomic number is 11, 3s1, outermost electronic configuration. So electron is there in the next group. So if I am considering electron in this 2s and 2p group, then contribution from last electron will be 0. Electrons which are right side to this electron under consideration, electron of our interest is what? 0. Could you able to understand this what I am saying?
Yes, sir.
Okay. If I have to describe one more, say, if I consider electron in the 3s, example, now under my consideration, it is my interest. Then if any electron is present in these orbitals, higher orbitals, those electrons will have no contribution for shielding. Outer electron have no contribution for shielding. If student is there at the 4th row in the classroom, then students who are at latter stage, 5th, 6th, 7th, 8th, 9th, 10th row, they will not affect, they will not repel, they will not divert the student. It is the second step conclusion. I repeat, in the first step, we understood the groups for electronic configuration. In second step, we understood the outer electrons are not going to affect the shielding. Now, see the third rule, it is very important, and those are the Slaters rules. One by one, the pay attention. Electrons within the same group shield to 0.35. Keep in mind, listen that if I consider 3s and 3p group, except the electron under consideration, other electrons have the contribution 0.35. But there is one exception, except 1s orbital, where shielding is 0.30. Means if I consider electron in 2s and 2p, one electron, then neighboring electron present in that group, contribution will be 0.35. Each electron contribution 0.35. But suppose if last electron or electron under consideration present in 1s, say hydrogen or helium, outermost electrons are there in 1s. In such cases, neighboring electron will have contribution of not 0.35, 0.30. It's only exception. The first point that I am telling now, neighboring electron have contribution 0.35, neighboring in a same group. Just listen now. When we'll apply, concept will be more clear. Application is one of the good method of learning. But timing, what I am informing, 0.35 for neighboring electrons in the same group. See the second point. For n-1 group, shielding constant is 0.85. n-1, n is under consideration. n-1 means lower. Again, if 3s is the electron under consideration, so it is in this group, 3s and 3p group. n-1 group means 2s and 2p. So in 2s orbital, suppose 2 electrons are there. In 2p orbital, 6 electrons are there. Total 8 electron will contribute. Each electron will contribute to 0.85 for those 8 electrons. For n-1, 0.85 is a contribution. Next rule see. Now listen just. For n-2 or lower groups, contribution is 1. If 3s, see by green color I highlighted that. If 3s electron is under consideration, then 2s and 2p, how much contribution? n-1, how much contribution?
0.85.
Right, 0.85. Then 1s will be with contribution 1.
0.30.
0.30.
No, not likewise. Listen, okay, here is a problem. If my electron under consideration 1s, then you are right, 0.30. But electron under consideration is, sorry, 1s, then you are right. If electron under consideration is 3s, could you able to understand what I am saying?
Yes, sir.
No color. If electron under consideration 3s, then what is our rule? For 2s and 2p, you rightly said 0.85, 0.85. For 1s, contribution will be 1.00. Here, I could not show by the drawing, otherwise it will be very good to inform. Okay, let me see. Yes, could you able to see now the whiteboard that I am showing?
Yes, sir.
If
Yes, sir.
electron under consideration is in the 3s and 3p group, electron under consideration, then neighboring electrons within this group will have contribution 0.35. It is our rule number 1. And whoever electrons are there inside, it may be in the 2s and 2p groups. 2p group, it's a n-1 group. This group is n-1 group. Yes, how much contribution?
0.85.
Right, 0.85. But if I consider one more group inside, that's a 1s, only one is there. It is my n-2 group. How much will be the contribution?
1.00.
Right, 1.00. To make this concept clear, I give you one more example. If I consider electron present in the 4s and 4p group, example, it is my nth group. Answer for my question. What will be the contribution from neighbor? Contribution from neighbor. N.
0.35.
Right, 0.35. Means if 5 electrons are there in this group, example 4s2, 4p3, this electronic configuration. 5 electrons are there in this group, then 4 electrons will be neighbors, and 4 into 0.35 will be the actual contribution. Could you able to understand what I'm saying?
Yes, sir.
Good. N-1 group is our 3D group. It is N-1. What will be the contribution?
0.85.
Right. Each electron will contribute 0.85. Suppose here 10 electrons are there, then 10 into 0.85 will be the contribution. Is it clear?
Yes, sir.
Good. Before that, 3s and 3p group is there. It is our n minus 2 group. 3s2, 3p6, suppose electronic configuration. Answer for my question. What will be the contribution of each electron?
1.00.
1.00 into how many electrons are there? 8.
8
That will be
electrons.
the total. Yes, that will be the total contribution. Let me continue further. Suppose if I consider 2s and 2p group. In that 2s 2 electrons are there and 2p 6 electrons are there. It is our n minus 3 group. Answer for my question now. That n minus 3 group, what will be the contribution of each electron? Here is the problem.
So 1.00 only.
Right, right. Don't think that only for one level 1.00. That level plus lower than that, whichever electrons are there, how many electrons are there, every electron will cause 1.00, right? 1.00 into 8 electrons are there. Now, suppose I continue it further. It's a further one more shell is left. That's a 1s group. It is our n minus 4th group. Will anyone answer? What will be the contribution of those electrons? Say here 2 electrons are there. What will be the contribution?
0.35.
No, no. 0.35 if that 1s electron is in my consideration, for which I am talking about shielding. Here my consideration point is this one. 4s orbital is my consideration point.
So
Are you
1.00 only.
right, right. Here 1.00 only will come. 1.00 into how many electrons? Say 2 electrons are there. So what I am finding, see, you are with confusion with rule number 1 and this rule number 3. Where is the confusion? You are thinking 1s means always 0.30. No. If electron under consideration, for which we are talking about shielding, if that's a nth group, then you are right, 0.30. If it is not nth group, then rule is different. Yes, students, are you understanding what I'm saying?
Yes, sir.
Good. Now see about this 0.35, an exception 0.30 I can say. It is what the nth electron. But if that is not nth electron, that's an n minus 1 group if it is there, then 0.8, sorry, nth group, general will be what the 0.35 in general. For S only it is a 0.30. If it is a characteristic electron, it is an nth electron, nth group electron, n minus 1 group, 0.85. N minus 2, N minus 3, N minus 4, N minus 5 is lower. It is what? 1.00. These are the 3 rules I told to you. But for ND and NF, means if the nth group is a d orbital, nth group is a f orbital, rule is somewhat different. See, if nth group is d or f, then within the same group 0.35 as usual. Within the same group 0.35 as usual. But for lower means n minus 1, n minus 2 and n minus 3, the answer will be, or shielding contribution will be 1.00. If I have to make this clear, then again I show you here the whiteboard. Let me consider electron present in, I write it by means of some thick pen, say 3D. Here electron is there under consideration. If it is in the nth group, then what is the contribution of neighbors? Neighbors in the same group? As usual, neighbors in the same group?
0.35.
Right, 0.35. But if electrons are there inside, means let it be 3s3p. Actually, it is a n minus 1th group. As per our current rule, what is the contribution for the 3s3p group?
0.85.
It was previously old first, but now if electron is present in that 3d or d or f orbital, then rule says in spite of 0.85, it is 1.00. Is this magic of this rule clear?
Yes, sir.
If we consider 2s and 2p, it is an n minus 2 group. What will the contribution?
So now it will be 0.85.
No, it is again 1.0. See, once 1.00 came, no, then it remains 1.00. All lower are there, no, every orbital will be with that 1.00. See here 1s. It is n minus 3rd group, n minus 3 contribution.
1.00.
Right, 1.00. So previously what was happening, n minus 1 was an additional step for which orbital if electrons are not present in d or f sublevels. Which electrons? Characteristic, outermost, electron under consideration. Means if I consider say chromium, an electron is in the 3d orbital about which I want to talk, then 4s electron will not involve in that. Outer electron is rule number 1. Electron present in that d orbital 0.35, and lower electrons is 3s, 3p, 2s, 2p, 1s will experience the 1.00. Yes, students, is it clear or shall I give additional example?
Clear, sir. But sir, when 0.85 will come?
Yes, I explained that. What are our groups? 1s is a one group. Please help me. Next group.
2s, 2p.
Right. Next group.
3s, 3p.
Right. Next group.
3d.
3D. Now question was when that point 85 will come. If my electron under consideration is in this group, it is my nth group, then contribution for that group will be 0.35. It is my n minus 1 group, contribution will be 0.85. It is my n minus 2 group, contribution will be 1.00. Are you following?
Yes, sir.
Because electrons are present in other than D and F group, outermost electrons. But if outermost electron is present in, I remove this now, outermost electron is present in this 3D, means it is our nth group, then what will the contribution for neighboring electrons? Neighboring.
0.35.
Okay, that's the usual. What about this 3s and 3p? It is n minus 1. As per
0.
previous conclusion, it was 0.85 as per previous conclusion. But it is not now. What is the answer? Here it is a
1.00.
1.00. It is n minus 2. What is the contribution?
1.00.
Right. Contribution is 1.00. It is n minus 3. Contribution?
1.00.
1.00. So what is the question? When that point 0.85 will come? If electron under consideration is other than 3D and 4s, in such cases, n minus 1 group will be with 0.85. Yes, students, is it clear? I want at least 3 replies.
Yes, sir.
Sir.
Good. See, rule number 1. Outer electrons have no any contribution for shielding. Rule number 2. Electrons in the group, nth group, will be with contribution 0.35. Except, tell me, which is exception? It is a 1s. It is a 1s group. If nth group is a 1s group, in such cases, contribution is
0.30.
brilliant answer. Rule number 3. Electron in n minus 1th group, contribution general way
0.85.
0.85 if nth group is not D or F. Okay. Contribution for n minus 2th group, second group, or n minus 3rd group, or n minus 4th group, so on. Contribution?
1.00.
Right, it will be 1.00. Are these points clear?
Yes, sir.
Here I had not discussed D or F characteristic. What are the nth? I am saying no. It is other than D or F level. But if in case electrons are present in D or F, then what are our rules? For nth, contribution will be 0.35. And for n minus 1, n minus 2, n minus 3, and so on. Help me. Contribution will be?
0.85.
No.
1.00.
Right. 1.00 is a contribution. These are the rules. Okay. Don't worry. If you're wrong, when you practice now, then concept will be more clear. And that is more important. Your practice, your work is more important.
Sir, but for
Say.
but for orbitals other than DF, we have n minus 1, n minus 2, 1.00, no?
Other than, I could not understand your question. Please.
सर मीन्स आपण वरती बघितलं ना अदर दॅन DF साठी n minus 2, n minus 3, 1.00. Then for D and F also 1.00.
Yes. For other than D and F, we started from n minus second. Are you getting?
Yes, sir.
And for D and F, we are starting from n minus 1. All those have 1.00 here. And here also, all those have 1.00.
Okay, sir.
Okay, good. Yes, is the question good question it was. Other students, did you get the question and answer that I provided?
Yes, sir.
Other students, what is the problem?
Yes, sir.
Yes, sir.
Good,
Yes, sir.
good. Now let us solve a few problems, actual problems. Yes, could you able to see the screen that I'm showing?
Yes, sir.
Yeah. The
Yes, sir.
example 2.6.1. Here, nitrogen atom electronic configuration is represented. What is that? 1s2, 2s2, 2p3. Second step, it is important. Grouping that electronic configuration in a group 1s2, 2s2, 2p3. What is our question? We want shielding constant for 2p electron present in 2p. Answer for my question. Okay, it is better if I show you on the whiteboard. Just wait. Question is 2p electron in nitrogen. Answer is electronic configuration of nitrogen 1s2, 2s2, 2p3. It is our first point. Second point, in groups, that electronic configuration can be represented as 1s2 in one bracket, means one group, 2s2 and 2p3 in other bracket, means other group. Will you help me to answer what is our nth group? It is our nth group, or this is the nth group. Which is the nth group? Electron under which orbital we want? It is a question. In question they give which is the nth group. Which electron we want?
2p.
2p. So it is our nth group. Nth group. As per our rule, neighboring electrons in that nth group will contribute how much? That's the calculation you have to do now.
0.35.
0.35. Right. Neighboring electrons. How many are neighbors?
4.
Right. Actually, there are 5 electrons are, but 1 electron is under consideration. So remaining 4 electrons will be the neighbors. So 0.35 into 4 plus. It is one bracket plus. Now it is our n minus 1th group. For n minus 1 group, what is the contribution?
0.85.
0.85. How many electrons are there?
2 electrons.
Right. See, now I come to that again, the previous presentation. See, 0.85 into 2 plus 0.35 into 4. What's the answer? 3.10. Could you able to understand what I'm saying?
Yes, sir.
Yes. So 3.10 is a shielding constant or screening constant. But if question is there, okay, in question they have asked only shielding constant. So it is right. But here, see a question. See, I'm highlighting that. Shielding constant. Question is shielding constant. But suppose if question comes, find effective nuclear charge, ENC. What's the formula? Effective nuclear charge is equal to atomic number, that's a Z, minus screening or shielding constant, that's a sigma. In our case now, nitrogen, help me, what's the atomic number of nitrogen?
7.
7 minus how much shielding constant or screening constant was there?
3.10.
Right. See, you are remembering it also. Brilliant. 3.10. So what will the answer?
4.90.
3.3. 3.9.
Are you getting or not? Am I right or not?
Minus 3.9.
Oh, 7 minus 7 is a large number. Minus 3.10.
Yes, sir. Right.
Yes. So actually 7 protons are there in whom nitrogen nucleus. But electron present in 2p orbital is saying only 3.90 protons are there. Means effective charge is only 3.90 despite of 7. It is because of screening and shielding. The screening and shielding we are calculating actually. So students, what I discussed today, I told you about the concept of screening or shielding. Already we had more discussion, but shortly I told you about that. Outer electrons have no contribution, neighboring electrons, inner electrons will have the contribution. Then we discuss rules. Yes, will anybody help me? The name of the rules? S. Which rules we discuss? Complete.
Slater's rule.
Right, Slater's rule. Then we discuss one example, that is of nitrogen, atomic number 7, and electron under consideration was in 2p orbital. Is this example clear?
Yes, sir.
There we
Yes, sir.
calculate screening constant. Okay, now see. Example is bromine. And electron under consideration is 3D electron. It is a question. What is given there? Write electronic configuration for the bromine. Yes, will anybody answer? What's the atomic number of bromine?
35.
Brilliant, brilliant. 35. So 35 electrons, how will you arrange? So I hope and expect that you know the electronic configuration point. Suppose if problems are there, you can ask the question, we will have the discussion. Let me complete this point. Electronic configuration, this one. In group, see, 1s is a one group, 2s and 2p next group, 3s and 3p next group, 3d next group, 4s and 4p next group. Question is about the 3d electrons. 3d electrons. Then answer for my question, shall I consider contribution of 4s and 4p?
No, sir.
Right, right. I should not consider. Now about the 3D. 10 electrons are there. How many neighbors will be there? For that one electron under consideration, how many neighbors in that 3D?
9.
Right, 9. And contribution from each will be for shielding?
0.35.
Right. Therefore, it is here. See, 0.35 into 9. Then as per our the rules for the D and F, inner electrons, whoever are there, means let you consider n minus 1, n minus 2, n minus 3. How many total electrons are there? 18 electrons. And those 18 electrons will have contribution?
1.00.
Right. Therefore, 1.00 into 18. So answer is 21.15. 21.15. What is that 21.15?
Shielding effect. Shielding constant.
Shielding constant. Right. Shielding constant or screening constant. But if question comes, calculate effective nuclear charge for bromine and electron present in 3D, then what will you write? That effective nuclear charge, it is represented Z star, Z asterisk is equal to atomic number of bromine, Z, minus screening or shielding constant. Help me now. What's the atomic number of bromine?
35.
And what is the sigma?
21.15.
Yes. Now calculate and tell me the answer.
13.85.
Brilliant. 13.80. Actually, 35 protons are there. But what that electron in 3D orbital is saying? Only 13.85. Means approximately 14 electrons are there. See how much drastic attraction difference is there. Change in the attraction is there. Experience of nucleus is there. That is because of shielding or screening. Very important concept. So we are doing the actual calculation for that. Yes, students, this second example, bromine, is it clear to you?
Yes, sir.
Yes, sir.
Yes. Here see, the boron and electron is in the p orbital. Boron electronic configuration 1s2, 2s2, 2p1. So in group 1s2, 2s2 and 2p1. Now in nth group, tell me, in nth group, how many electrons are there?
3 electrons.
Yes, how many are there? 3. So how many neighbors are there?
2.
2 electrons.
2. So factor will be?
0.35 into 2.
Right, therefore 0.35 into 2. Now, n minus 1th group, how many electrons are there?
2 electrons.
What is the factor?
0.85.
Yes, 0.85 into 2. N minus 1, how many electrons are there?
0 electron.
Listen, what was my question? N minus 1. N minus 1.
2 electrons.
Right. N minus 2.
0 electrons.
Right, 0. And contribution is what? 1.0.
0.
Yes, then 2.40 is a shielding constant or screening constant. Effective nuclear charge is equal to that Z. 5 minus 2.40. Answer is 2.60. Is that example clear?
Yes, sir.
Yes. Accordingly, now homework. Next time we can have discussion for D electron in copper. Copper atomic number is 29. In examination, you may get the atomic number value, especially if the transition series metals are there or high atomic number metals are there or elements are there, not necessarily metals. So it is a work. Is it possible? Will you work for that copper and 3D electron?
Yes, sir.
Yes. Yes. It is a courtesy to this LibreText website. Because of that, I could able to explain that. Even if you go to Wikipedia, you will find the examples. Yes. So students, today I plan to cover that effective nuclear charge calculation point, Slater's rule, that I covered. Actual quantitative answer for shielding constant or shielding or screening constant that we have what discussed. Is it clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Actually, today I was with one workshop. Workshop extended, and therefore I could not start our lecture in time. Actually, at 2 o'clock we start lecture. No, so at 2:15 about we started the lecture, but we took that sufficient time. Yeah. If you have any doubt or any question, we can have the discussion. Now, tomorrow's lecture I want to spend for electronegativity point, electronegativity and calculation of electronegativity. Afterwards, one more lecture may be then needed. So you can tell me tomorrow when shall I conduct the lecture for revision. Or if you are in doubt, we can have discussion. If no doubt, then lecture period will be the very short. So in examination, you can want the attempt. Further, if you need further guidance, you can ask question on WhatsApp also, or you can call also. But understanding is important. Paper 1 and paper 2 study that you need to do. For paper 2, I provided the study material, and for discussion, I'm ready for discussion. And for paper 1, videos are given, assignments are completed, and discussions also are done. Any doubt or any question now?
No, sir.
So students, shall we stop now?
Yes, sir.
Yes, sir.
Okay, students, then I stop the recording.